Algebra 1, section 9.6. One more time, you should have already done section 9.8 before doing this section. If you have not done 9.8 yet, you should stop this video, go watch the 9.8 videos. But there are two of them, part 1, part 2, and do that homework. This half of what I'm going to do here is not going to make sense if you don't know how to do factoring by grouping. Okay, so we're going to do 3 examples here, and I'm going to model this for you 2 ways. And what you're really going to need to do over the course of doing this section, and I don't mean just listening to my video, but through practice, as you practice the homework, maybe practice a few each way and decide which one you're comfortable with. By the end of this section, you ought to have a firm idea that you are one who either factors by grouping, which is a little bit more systematic but requires a little bit more paper, or if you are trial and error, which is not as systematic. You can still be systematic about it, but you can end up trying a lot of parts, a lot of different components before you get the ones that work, but requires less paper. Okay, so I'm not going to try to steer you one way or the other. In fact, my goal here is for you to not even be able to tell which one I prefer. Okay, so we're going to do these both ways. This is, as far as grouping goes, this is somewhat review of the last part of 9.8. AC, 20 times 3 would be 60 if I do this by grouping now. And I'm looking for numbers that have a sum of 17. 1 times 60, 2 times 30, 3 times 20, 4 times 15. We're getting close, but not there yet. 5 times 12, that would be the one. 5 times 12, those are the 2 numbers we're going to use. And you rewrite 20 x squared plus 5x plus 12x plus 3. And again, I already modeled this for you once as well. If you flipped the 5x and the 12x, the way this goes would look slightly different. At the end, your parentheses will just be reversed, exactly reversed. I don't mean mixed up. I just mean the first set of parentheses will be in the second position. The second set of parentheses will be in the first position, just as they are. From what I get right here. Anyway, I'm going to factor by grouping by taking out a 4x here, which would leave me with 5x. Oh, sorry, not 4x. 5x, which would leave me with 4x, plus 1. And here, we can take out a 3, which would again leave me with 4x plus 1. And this is then 5x plus 3 times 4x plus 1. This is factoring a trinomial using your knowledge of factoring by grouping. Now, let's suppose, let me just rewrite the problem again. Let's suppose you're not a factoring by grouping person. You've practiced this a few times. Maybe you practice it again in 9.6 and you decide that you're going to try a different way, or you'd prefer a different way. The other way is simply trial and error. Now, I have my own set of directions for trial and error. So if you're going to be a trial and error person, you haven't heard me say this before. And my advice to you, if you're going to do trial and error, is start with numbers that are closer together. Okay? So similar to the questions that I asked you in section 9.5, back when the number here was always 1, is, when it comes to the constant, you want to know what number I can put in each place here, or term I should really say, I could put in each place here that would multiply to give you 20x. Well, that could be 1x and 20x. It could be 2x and 10x. It could be 4x and 5x. And that's going to have some compatibility issues with the numbers that go into the constant too. So this truly is trial and error. My advice to you, only because I know the way these problems tend to be written in textbooks, would be to start with the numbers that are closer together. So don't start with 20x and x. Start with 5x and 4x. No guarantee that this is going to be right. Again, this is, after all, trial and error. And you try 1 and 3. Again, trial and error. This is one of the reasons you want to use pencil. I always require you to use pencil in math. Even in quarantine, you ought to be using pencil. Because I go ahead and I plug in 1 and 3, and then I look at, and what I want to look at more than anything is the O and the I in FOIL. I know 5x times 4x is going to give me 20x squared. I know 1 times 3 is going to give me 3. But I want to look at 15x here and then 4x here and see if there's any combination of that that's going to give me 17x. In particular, I want to know about a sum, right? So is 15x plus 4x, does that add up to 17x? No, it does not. So flip them around and write 3 and 1. And you know what? If 3 and 1 don't work, then you're going to have to scrap 4x and 5x and 4x, and try one of the other ones. Try 2x and 10x. If that doesn't work, try 20x and 1x. This is the nature of trial and error. But actually, we know that 3 and 1 are going to work because we can see the answer above already, and they're both going to be positive. Let's just double check that. 20x squared plus 5x plus 12x. 5x plus 12x will give me the 17x, and then 3 times 1 is 3. Okay, so two different methods to come up with the same thing. 5x plus 3 times 4x plus 1. Let's try that again. Let's do this in reverse order this time. Let's do trial and error. So if you're a trial and error person, you want to get your parentheses. For both groups, you do want to make sure that you don't have a GCF, right? And that's something that I should start saying more and more, and you should start looking for more and more. Look and see if there's a GCF. Not only is it required as being part of your fully factored polynomial, but also it'll make factoring easier. If there were a number that I could divide out of 3, 7, and 6, I should do that. If there were a variable that I could take out of all three terms, I should do that. But there isn't. Okay, so the next step then is to go with the numbers that are closest together. In the case of 3, which is a prime number, it's got to be 3n and 1n. Okay, and then you have numbers that would multiply to give you 6. And again, what I would suggest to you is going with numbers that are closer together. So go with 2 and 3. Right? You could use 1 and 6. You could use 2 and 3. I'm suggesting 2 and 3. In fact, let me just do it wrong first. Let's take a 3 and 2. And here you have 3n squared. The L in FOIL would give you 6, but we're interested in getting a difference, right? Because of this, a difference of 7. And here I have 6 and here I have 3. Well, the difference of 6 and 3 is not 7, so flip them around. And if that doesn't work, if 2 and 3 doesn't work, well, then I'm going to have to try 1 and 6 and 6 and 1. 2 and 3. But actually this one will work because, again, the O and the I in FOIL, the outside and the inside multiplication. Here's 9n, here's 2n. Those have a difference of 7n. The last thing to do with that would be to then assign the symbols that are appropriate. Again, 9 and 2. Here's a negative 7. We want then the bigger of the 9 and 2 to be negative. Negative 9n plus 2n would give me negative 7n. That's trial and error. Now again, if you're one who factors by grouping, well, AC, 3 times 6 is 18. We're looking at 1 and 18, 2 and 9, or 3 and 6. Which two have a difference of 7? It's 2 and 9. So we rewrite this and we go 3n squared plus 2n minus 9n minus 6. Or 3n squared minus 9n plus 2n minus 6. I showed you in a previous video how that would produce the same answer. Factor by grouping. Take out an n here, 3n plus 2. Take out a negative 3 here. That's the GCF. I don't have some kind of foreknowledge. I didn't look up here. I know I'm looking at the GCF. And you can take a negative 3 out, which will turn the signs to positive, which we need because these are positive. And the GCF of 9 and 6 is 3, which would leave me then with 3n plus 2. So n minus 3 times 3n plus 2. Either of these is correct. The only difference between the two answers is that the parentheses are reversed. One more. Factor completely. Now the directions will always say, or should always say, factor completely. It makes me think of a GCF, and I can see right now that this problem is going to have a GCF. All three of those terms are divisible by 3. And again, more and more, and just as kind of a regular practice now, look ahead to see if there's a GCF. Stop and think, especially trial and error. If you're going to do trial and error this way, 18 for x, you're going to have 1 and 18, 2 and 9, 3 and 6. For 30, you could have 1 and 30, 3 and 10, 5 and 6. That is a lot of combinations. If, however, you would divide out the 3 first, that would leave you with 6x squared plus 11x minus 10. The possibilities get cut way down if you can factor out a GCF. Okay, now let's do grouping first this time. 6 times 10 is 60. We're looking for a difference of 33. 1 and 60, 2 and 30. I'm sorry, not 33. A difference of 11. Difference of 11. The 3 is already taken out. I'm looking inside the parentheses here. 60, I'm looking for a difference of 11. 3 and 20, 4 and 15, and there you go. 4 and 15 are different by 11. So rewrite this as 6x squared minus 4x plus 15x minus 10. Which I can then take out. I like to draw a line in a different color there just to keep things as clear as possible. 2x, take out a 2x. Leaving 3x minus 2 plus 5, leaving 3x minus 2. So don't forget your 3 as part of your final answer, and then 2x plus 5, and then 3x minus 2. This is completely factored. Okay, one more time for those who might like trial and error, you should still divide out a 3 first. 3 times 6x squared plus 11x minus 10. And then your final answer should have the 3. And then 2 sets of parentheses that we can factor this. Now, again, your numbers for 6 could be 2 and 3, could be 1 and 6. My suggestion, no guarantees, but my suggestion is to start with 2 and 3. The way these problems tend to be written, those numbers will be closer together. It could be 6 and 1, but I would start with 2 and 3. Same thing with 10. I wouldn't start with 1 times 10. I would start with 2 times 5. And if I put a 2 here and a 5 here and check, 2 times 5 is 10. 2 times 3 is 6. 10 and 6 do not give me a difference of 11. So erase, trial and error. Try 5 and 2. If 5 and 2 don't work, try 1 and 10. If 1 and 10 don't work, try 10 and 1. If that doesn't work, then you're going to have to scrap the whole thing, go back to 6x and x. Try the same combination of numbers. This is when you're at a disadvantage when you're using trial and error. Sometimes it works out better, sometimes it works out not as well. Here you're going to get it. Here we have 4x, here we have 15x. Those are different by 11. You want this to be positive, so the 15 should be positive, right? 5 times 3, if they're both positive, gives you 15, whereas here's negative 4 if I make this negative. And that's exactly what I got up here. So again, grouping, trial and error, you decide, maybe practice a few each way in the 9-6 lesson, and as you come out of this lesson, that's really a decision made, and that's the way you're going to do it at least for the remainder of Algebra 1. Thank you.